In this video, I'm going to show you all how to calculate Anova in Excel. Okay, so the two variables that we're going to be using for this example are going to be child del, so ideal number of children, and degree. Okay, so the degrees are going to be our different samples, or the categories of the degree are going to be our different samples. So less than high school, associates, bachelor's, graduate, and obviously child del. We're going to see whether or not the mean ideal number of children for these various education levels is equal. Okay, so what we're going to do is we're going to copy these two, child del and degree, and then we're going to paste them in a new sheet. All right, so that's the first step. Now the second step is to get rid of any missing data. Now with the variable degree, I don't really think that there's any missing data. I think with child del I know with child del there is some missing data. So -1, 8, and then 9, but nobody's put down 9 is missing data. And I think degree, yeah, so there's no missing values for degree, so we can just go ahead and like clean up child del. So we need to get rid of -1 and 8. So I'm going to come over here. I'm going to highlight this and press Control F. So I'm going to replace -1 with just blank, and then I think 8 was the other one. Okay, so we got rid of all the missing data. Now what we need to do is we need to put down the different categories. So like I said, with degree, I think that there's less than high school. So I'm going to put down LT high school. There's high school, associates, bachelor's, and then graduate. I'm going to expand these so we can see them a little bit better as well. Okay, now that we have that, what we need to do at this point is we need to now sort the data. So I'm going to come up here to data, and I'm going to hit sort. Then I'm going to sort by degree. Degree, then I'm going to sort on value, and then smallest to largest. Okay, now if we look back at the code book, we see that 0 for degree is equal to, I think, less than high school. So 0 is less than high school, 1 is high school, 2 is junior college, 3 is bachelor, 4 is graduate. Okay, so now that we have that, we're gonna go find everybody who's 0, we're gonna put them in a less than high school category. So all these people identified as being less than high school levels of education, so we're gonna copy this. We'll copy it until we get to the last 0. Okay, so we're at the last 0. We're going to copy this, and then we're going to put that data here. Now we need to find the ones to put in high school, in the high school category. Okay, so copy that. We're going to get all the ones. We're going to put them in high school. Okay, now we need to come down and we need to find the 2s, 3s, and 4s. So let's go find the 2s. Now we need to go get the 3s. And then the last one, we'll go get the fours, everybody who says that they have a graduate level of education, so masters and higher. Okay, so now we have our 5 samples, 1, 2, 3, 4, 5 samples. So we're going to compare the means of these 5 different samples. Now the way we're going to go about doing this is we now need to go to the data tab and find data analysis. So we'll click on data analysis. And then we're going to do Anova single factor because we're doing one-way Anova. So we're going to click Anova single factor. We're going to press OK. Okay, good. Now, as far as the output range, I'm going to put the output just here, just kind of close to this. And then for the input range, we need to copy all the numbers less than high school to graduate. So I need to go take from here to till we run out of data. Okay, so I got that, and then that will be my input range. Okay, now the alpha level 0.05, like I said, I could do it 0.01 or 0.001 if I wanted to, but 0.05 will just be fine because we just want to see whether or not we're going to reject or fail to reject the null hypothesis. So I'm going to press OK. And then I should get my information that I request up here. Okay, good. So we have a NOAA. So column 1 is less than high school. So I'm just going to expand this a little bit and then put LT high school, associate, and then graduate. Okay, so I have the count, I have the sum, I have the average, which is the mean of all these different groups. The variances are all relatively kind of close. So here we have the F, and then we have the F critical. So these are the important things. This is the degrees of freedom. So degrees of freedom 4, which is degrees of freedom between. So it's the DF1, and then this is DFW, so degrees of freedom within. So if you were to look at that chart, what you'd do is you'd come over to the distribution of the F. Expand this a little bit. So you'd come over to the distribution of F. So you'd see that degrees of freedom between is 4. So you'd go here. I think the other degrees of freedom was 879. So you would come back, then you'd just go to the last one, which would be 20. So 4, 20, and then your F critical would be around 2.87, so somewhat similar to that. So now that we have our degrees of freedom between, degrees of freedom within, you would calculate your F. And then so your F obtained is 7.86, 7.87 if we're rounding. And then you would compare that to our F critical, and we can see that our F obtained is above our F critical, so that means that we can reject the null hypothesis. The other way that I know is because, again, if you look at the p-value is a negative 6 decimals. So meaning that like the p-value is below the 0.05 alpha level. So that's how you would go about determining whether or not you're going to reject or fail to reject. So we would reject the idea. We would reject the null hypothesis. We would reject the idea that the means of all these different groups are equal in the population. I just realized why there was such a big discrepancy between the F critical here and then what we have here. So this is an incomplete chart. If you actually go to the actual distribution of the F down here, it actually goes to an infinity symbol, which if you carry that over to the fourth one, it's 2.37. So that's actually consistent. So the F critical that Excel gave us is actually correct. Yeah, so again, even regardless of the situation, we know that with our F obtained of 7.86 0.868 and so on, number. We know that we would reject the null hypothesis given RF obtained. And also, if you look to the next page, you can just look at this on your own. For the 0.01 alpha level, you'd also reject for the 0.01 alpha level. And you'd also do it for the 0.001 alpha level as well. All right, so that's how you go about calculating ANOVA with Excel.